First of all, a lot of the manufacturing facilities that we have still have got legacy systems. There's a lot of old equipment still left in many of these plants. If you take powertrain plants, for example, across the automotive industry, that was supposed to be phased out by 2030. So not many companies were putting a whole lot of maintenance effort and capital equipment improvements in powertrain plants. In assembly plants, likewise.
Today's episode is something else. Mark and Bruce are legendary. That's the word I want to use. And, OEM and suppliers all in once. This is a special conversation. What did you think, Jennifer?
God, that was phenomenal. Just the amount of experience and breadth of knowledge that they bring to the table was just fascinating. Some of the specific challenges and opportunities that are in the automotive industry, and to be able to unpack some of that with people that are this experienced and this, knowledgeable about it was really fun.
Man, I wish we need more time to dig both of their backstories too. We just give a bit of it, but it's great. People are gonna love hearing that. And I don't know, just crossing from all aspects of manufacturing and the car out. I mean, this is, let's not spoil it, I guess, but this is a special episode.
Yeah, there's a lot to get into. Let's do it.
Let's get into it.
All right. Well, today we're excited to have not one, but two incredible guests on the show, each bringing decades of experience leading transformation in the automotive industry. Bruce Coventry is the CEO of Coventry Consulting and former executive at Chrysler, GM, Ford, and Mitsubishi. He's helped guide both major OEMs and startups through some of the most pivotal technological shifts in modern automotive history. Joining him is Marc Rosenmayr, a global innovation leader and senior advisor with a deep track record in power electronics, wireless charging, and smart systems. From Hella, where he served as CEO of electronics, and Motherson, where he served as CTO, to his work advising a range of mobility and energy startups, Marc brings a sharp lens to the future of automotive technology. Together, we'll dive into the front lines of automotive transformation, how electrification, wireless power, and factory intelligence are shaping the future of mobility. Bruce, Marc, welcome both of you to the show.
Thank you.
It's great to have you both here. Been looking forward to this conversation. Bruce, let me start with you. You've helped lead transformation across multiple OEMs. What first drew you to automotive, and how did your early experiences shape your approach to innovation?
It's a long story, but I'll try to keep it very short. I started when I was 17 years old as a cooperative student working for General Motors. I actually started working for GM a week before I graduated from high school. And I wasn't old enough to actually go out on the factory floor in New York where I was working. You had to be at least 18 years old. So at that time, General Motors was one of the few it was the only company in the world that had its own fully accredited engineering and management university. And that university is now known as Kettering University. And it is, of course, a wonderful place to get a really hands-on education. But it was not an easy program. They squeezed 4 years of engineering and management work into 2.5 years. The other time you were spending in the factory or in your sponsoring company working, and applying that knowledge that you were gaining at the university. So it was just a fantastic way to really get to understand. I can't tell you how many times, the light bulb went on and said, oh, that's what under the area of the curve really means. Okay.
Wow, what a great program.
So being able to conceptualize both theory and practice was just a wonderful thing. And the way the program worked is that for the first 2 years of the program, you were essentially like an apprentice. You were paid the exact same as an apprentice, and you'd work alongside with hourly employees. So they'd throw you right in, you'd work on the line, you'd perform regular hourly duties and work right along with a lot of the skilled trades and other areas. Then in your last 2 years, of course, it was all engineering. And it was a fantastic opportunity because I learned some of the smartest people in the industry were the people running the machines. And that was one of the early lessons that I got out of that program, was that even to this day, it was such a profound lesson that, you really got to respect the people that were on the floor not just as peers, but because of the knowledge, that they had gained over the years. And they knew their equipment, their machines, their processes inside and out. And that
Hmm.
was helpful. And, it was a lesson learned.
That's incredible. Thanks for sharing that. I
Yeah,
wish,
that's
uh,
fun.
I wish my education had been a little more half applied, half theory like that too. It's awesome.
Yeah, it's fun to see where people get their love for manufacturing, where it starts, and then how it grows out from there. Mark, I want to kind of switch over to you. You've worked across global automotive supply chain, um, leading teams through product innovation, high tech integration. I would imagine there were some pivotal moments along the way that kind of helped shape your career path. Uh, you tell us about some of those that might have shaped where you are now?
Yeah, yeah, absolutely. So I had a PhD from the University in Zurich and in electrical engineering. But I joined automotive mainly because I was really drawn to the embedded electronics. I did PhD work already. We kind of designed a complete inverter, and I did programming myself. And I just liked that kind of engineering work. So automotive seemed to be a good fit to apply my expertise I acquired during the university education. And then I joined Hella in Germany. So that was back then a family company, not as international, global as it is today. Everything happened a little bit more local and in smaller teams, but I had the opportunity right from the beginning to work on new cutting edge technology. So back then, in the year 2000, automotive supplier and the OEMs, that means the original equipment manufacturer, tried to solve a problem with the energy consumption in cars. The cars had more and more electronic on board, more and more control units, and the battery just wasn't able to power all of that altogether. And they have seen S-Class, Mercedes S-Class, and BMW 7 Series that they have drained battery after just a couple of weeks. So they tried to solve that, and they asked Hella to develop a completely new product, which was a battery sensor. And I really enjoyed that work, starting with a clean slate, finding what's the right technology here. And then I had the opportunity to build a team to do all of that. So that really got me exposed the first time to innovation in automotive. And then later on, as I came to the US, we brought a number of new technologies here. So 24 gigahertz radars, for example, was one of them, which wasn't used here in the region. And then Hella and my team had the opportunity to implement that. Maybe the most pivotal moment in my career was as I transitioned from the engineering to the business side. I took ownership of a global product line, and in addition to defining the products and developing them, I was now responsible for profit loss of this product line. And later on in my career, as I joined Madison Innovations as a CTO, I got truly exposed to innovation. We were not just working on the next generation of products, but we were looking like 5 or 10 years into the future. And that was my sweet spot. So this is what I'm still doing today, working with startups in cutting edge technologies.
Hmm. That's awesome. That's a great
Yeah,
story, Mark.
that's fascinating. I think about that. Bruce, you heard Mark talking about, the ability with Motherson to kind of look down the road, 5 to 10 years. That's visionary. That's impressive. You contrast that against, a lot of automotive suppliers are still running really decentralized now, like, lag style operations, meaning local accountability, global support usually translates to less influential global engineering initiatives and limited cross-site digitization. We see that a lot with our customers. I'm sure you do as well. Um, why do you think that the automotive sector seems to be a little bit slower in adopting centralized AI-enabled practices? Do you think that's true? And if it is, then what do you usually advise to accelerate change?
Well, I think it is true. And the reason it's true is really multifaceted. Um, First of all, a lot of the manufacturing facilities that we have still have got legacy systems. There's a lot of old equipment still left in many of these plants. If you take powertrain plants, for example, across the automotive industry, that was supposed to be phased out by 2030. So not many companies were putting a whole lot of maintenance effort and capital equipment improvements in powertrain plants. In assembly plants, likewise, you've got, some old body and white equipment, robots can be replaced or refurbished, and you get equipment like that. But um, maybe even more importantly, that equipment, that was in the facilities, let's just say it's over 10 years old, was never designed with the kind of sensors and the kind of, um, uh, ability to communicate with the on-floor systems. So that's one. The other, and this happened very early in my career. When I was growing up in manufacturing, I thought everybody was from Missouri, because all I kept hearing was "show me," prove it to me that this works. And it's for a lot of reasons, but I think one of the big reasons is safety. You look at a manufacturing floor, and a well-designed, well-implemented manufacturing system isn't necessarily inherently dangerous, but it is inherently unforgiving. So if you do something that violates a process or a system, um, you can put yourself in the wrong place at the wrong time. And I think that's one of the factors. Now you're talking about maybe letting them, an AI make a decision that could impact safety. So there's a lot of conservatism in manufacturing. I think that that's one of the issues that just has to be recognized. Um, the other are the big data and connectivity gaps. As you look at these systems, um, a lot of them, are legacy systems. They don't talk to each other. Um, the sensor coverage, if it exists at all, is inconsistent. So you don't have, a standard approach at all of these sensors. So it takes a long time, to be able to develop the APIs and so on, to make sure that all the sensors can talk to all the systems. But you've got MES systems and ERP systems and quality control systems that may not talk to each other on the manufacturing floor. So that's another lag that has to be overcome. And of course, you've got cultural and skills barriers.
Mm.
Right now, in many of the manufacturing plants, you see CNC equipment or robotic equipment that really does take a higher skill set to be able to run. And as we start looking at how we're going to run manufacturing facilities in the future, you have to think that literacy and educational level and other skill sets will start to become more and more of a factor as the plant continues to get more complicated and more advanced. Um, and then I guess the last is really just the budget cycles and the money, the return on investment. Some of these systems take a long time to prove out, particularly if you've got some of the problems that I described earlier. So I think, you've got all of those things that make it a little harder for, companies, particularly companies based on AI, to come in and be able to prove themselves. So, if you ask yourself, how do you overcome that? You really have to look at what, what are we going to do in order to break some of those bottlenecks, and really, being able to develop some sort of incremental integration plan. You're not going to do it all at once. You've got to be able to go in and take bite-sized chunks and demonstrate that this works, that it is safe, that it can perform as advertised. And the benefits are just enormous when you think about what this type of AI can do for manufacturing facilities. We've got data. What we don't have is action. And that's one of the things that I think is so critical about this type of an approach, is that it literally can drive action within the manufacturing plant. You hear a lot about lights out facilities, but I mean, this is a key enabler to make that happen. Being able to demonstrate that AI can actually run operations and make decisions that will work in the customer's favor and in the operator's favor if necessary. So
Yeah.
There are a lot of different ways to approach it. You could do a hybrid approach where you keep the safety critical controls. Let those stay local, and then do some sort of a higher level AI implementation. Um, you've got to build trust in the system, so those pilots become critical. So start with small, measurable AI projects, and then work on things like predictive maintenance or scrap reduction, or just run them maybe in a shadow mode, so they're running in parallel with the normal system, but show how much better they are, and what actions they can drive to save money and to improve results. I think that's a critical. And then, of course, you've
Yeah.
got to make sure that you've got the right cross-functional teams. You've got to pick the right partners. You've got to have the right people in the plant that can cover it, and you have to have the right skill sets. And then, and one of the things that I think is lacking in many of the manufacturing operations I get an opportunity to visit these days is just the overall governance. You know, in the absence of a clear understanding of who does what by when, you're gonna get a lot of variation in the results, because people are going to do it the way that they've always done it, or the way they did it in their last company or the last job, or they're going to invent something. So that's why having a standard process that's very rigid and very structured becomes really, really important. And like any kind of a trial or improvement like this, you just have to focus on getting early wins. Small, you know, achievable, but early wins that can show and demonstrate the kind of opportunity that this technology can bring.
It's fantastic. I agreed.
There's so much good to unpack there. The the running a shadow system on the side, the engaging the right people, the cultural transformation. You kind of talked about the balance between standardization, needing a core standardized system, but then going use case by use case and getting value. And as you were talking about that, I was really thinking about the role of engineering leadership as well, because you talked about, in general, people often talk about IT OT conversions, and like, where's engineering ET in that picture? And when you have just a big, not to push back on IT, but if you have a big IT project, that brings some of the standardization and the networking, but that can delay the time to value and the payback periods in individual factories, and it conflicts with that lags culture of, what's this one site going to do. So I think that's really the place where engineering leadership is so critical, to have engineering champions who look at initial use cases and quality, whether it's quality or maintenance or process control. So Mark, I want to bring you a question about this, because you've worked with startups, you've worked with larger companies, you've worked with engineering leaders on various ends of the spectrum. What's your perspective on engineering leaders in automotive who, it seems for the most part have focused on design and focused on new product challenges? That's what was sexy and interesting, so to speak. But now there's really important factory AI challenges and factory transformation challenges. How are companies trying to engage their best engineering leaders to get involved in these and bring these payback periods down with really successful projects?
Yeah, look, keep in mind that large organizations like Hella or Madison, they have been successful organizations. They've been around for decades, or like Hella, even more than a century. They really are good in what they're doing, based typically on past best practices, right? So they optimize whatever they have done, both on the engineering side as well as on the manufacturing side. But the engineering side, the product innovation is typically driven by the client, while the internal optimization is driven out of the own company. And in particular, the suppliers have pretty thin margins, right? So they need to be very focused on where they are spending the investment. We already talked about, the return on investment and how can you optimize systems as an overall organization. So I think what has changed really with the implementation, or with the availability, I need to say, of AI solutions, is that this can completely transform how you do things. And organizations, suppliers in particular, they have a number of different stakeholders. And as a startup, if you want to showcase that technology, if you really want to prove to an organization that your technology can help them, it's so important that you work with all the stakeholders. So on one hand, you have the operation excellence team. This is typically central organization, which is exploring new technologies, which is definitely following, what's going on the digital transformation. But they build up the knowledge. They don't necessarily have a budget to implement it. Then on the other side, you have the local teams, down in the trenches, which are building products, as we speak, and try to ship them out of the door, and are fighting, logistic and quality challenges. And they normally don't have extra capacity to really work on these new technologies, but they will ultimately benefit from. So that's another stakeholder. And then the third one is really global management, right? Which gives the directions, which allocates budgets. And I think it's so important that we work with all of the different stakeholders and ultimately even include IT. A lot of the new solutions are coming cloud-based, are coming as web-based applications. And that means IT will have to review them. What's cybersecurity risks here, for example? What are potential implementation challenges? And all of these stakeholders need to align before you can move forward. And that can take a long time in a large organization.
Yeah, absolutely. Yeah, and the role of that, I think that engineering champion that sees those initial use cases that really have big payback and big value in the factory can get you through that whole period. The security review, the alignment with IT, OT, management, all the stakeholders, like you get lost in that unless there's this really clear use case. Maybe it's AI to fundamentally solve some downtimes, or it's a maintenance transformation, or it's a quality one, but it's really clear and known why it's valuable for the organization. So yeah, I like that. I want to build on that question a little more. So Elon Musk, love him or dislike him, but he's done a lot of interesting things for manufacturing. And, with Tesla and the automotive space, something that he's really pressed on with his engineers is like the factory is the product, right? Not just the car, not just the cool electronics and its controls, like the factory itself is the product. And he's tried to elevate the importance of that. And I guess I want to push that question to both of you. Maybe Mark, you first, building on the last one, and then Bruce. But how do you view that mindset? Like, does that make sense to you? Is that like kind of a silly thing that Elon says, or is there some deep truth to that? And what are the biggest barriers preventing traditional automotive suppliers from embracing this idea that the factory is product, right?
Yeah, so I think with Elon Musk and Tesla, the industry almost went full circle, right? If you think back how it started with Henry Ford Model T, with the assembly line, they really were able to handle that kind of complexity of the cars, together with the speed, and reducing the cost by the principle of divide and conquer. So every car was now built out of thousands of parts already then. Today we're talking about like typically 20, 30,000 parts which go in a car. And they were distributed across the supply base. And that supply base was built over all that time, introducing tier ones. So that's suppliers which are directly shipping parts to the OEM, to the car manufacturer. Then there are tier twos, which are supplying to the tier ones and tier threes and tier fours and tier fives. And all of these companies now are focusing on their specific technology and their specific parts, right? The industry became so cost efficient because certain companies are doing nothing else than a certain little fixture part, for example, or electronic components, just resistors or capacitors or microchips, something like that, So the challenge here really, which Tesla approached in a different way, is most companies lost that system thinking. How can we optimize the car as a complete system rather than just building it up from optimized parts? And because of the complexity and the increased use of software, which just added another layer there, it became very, very challenging for OEMs. And with the existing structures and how they managed suppliers, approved their parts and implemented them, it takes them a long time to move back from that model to building up the system and car competency in-house again. But they are doing that, right? We see that the GM is bringing back a lot of that capability, that Ford is bringing back a lot of that capability. Same in Germany with OEMs, Mercedes, BMW, because they realized unless they really optimize the complete car first, they will not be able to compete with the newer companies like Tesla and others.
Yeah, from extreme specialization and just assembly of parts to an integrated systems thinking, software-defined vehicle. Bruce, what's your take on this?
Well, it's funny. A lot of auto manufacturers, or a lot of people within the auto manufacturers, don't even consider Tesla an auto company to begin with. They think they're more of a software company, and that's the focus. At least when you think about their manufacturing processes, that's where the thinking comes from. They think like a software company, not like a traditional auto manufacturer. You see that in the way that they bring over-the-air updates to the market, the way that they will work with different technologies and then roll them out and let the customers tell them what that's like. Well, a lot of that transfers to the manufacturing floor too. The one thing that I can say about Elon Musk is that I respect his ability to learn from his lessons in manufacturing, because here's a guy who's putting rockets in space, doing phenomenal things, grabbing rockets as they come back down with gantries and things like that, doing all these spectacular things. And yet, when you ask him about what the hardest thing he's ever done is, he called it manufacturing hell. Having to launch a Model 3, in a given time frame, you've got a launch date, you've got to go ahead and get the product there. And I think because of those lessons that he learned, he really appreciates, how complicated manufacturing can be. Maybe the easiest way to look at it is just to compare and contrast the way that Tesla does it, versus the way that, a lot of automotive companies do it. So, the Tesla factories are continuously evolving the product itself. And, they look at the plant as the product, not the vehicle so much, but the plant itself. So if you look at their product cycles, they're a lot longer than a traditional manufacturer. The Model S, I think, is 10 or 11 years out there without a major refresh, compared to every 3 to 5 years that you see, in some cases even sooner. Some of the other manufacturers are updating their designs. Whereas, the OEMs, they look at a factory as it's a fixed asset. It's designed to deliver a specific project or product, and to do it, with maximum repeatability. So it's built around quality, repetition, cycles of learning, that type of thing. If you look at speed, iterative speed, traditional manufacturers focus on cycle time, looking at how many parts per day, how many parts per hour, how many parts per minute you need to get out of that machine. Whereas, and then once you get it dialed in, don't change anything. So that's typically the mindset. At Tesla, you see a continuous process of changes. Sometimes weekly, they integrate hardware and software updates. They're constantly changing and iterating. So that would drive traditional auto manufacturers crazy, because they don't want to see it in their supply base either, that kind of activity. But it's the way they do it, and they generally improve. If you look at vertical integration, Tesla takes the product all the way back to the mine. They've got control over the process all the way back to bringing, the materials out of the ground, lithium and cobalt and other materials like that. Whereas most of the OEMs are built around having an integrated supply chain that can be managed, but it requires a lot of effort to manage that. And then in terms of automation philosophy, the automation in a typical plant is really built around, the business case. Can you justify the automation? Now, as labor costs start to exceed $75 an hour, it's becoming easier and easier for most manufacturers, at least at the OEM level, to justify that automation. But, that's one of the biggest reasons for job losses in North American industry is really that level of automation has improved so dramatically and increased so dramatically over the last 20 years. Um, Whereas on the Tesla side, they aggressively experiment with automation, but they go lights out if they could. They're very, very aggressive in how they apply automation, and they'll work really hard to drive that into place. So those are just some of the changes that I see, or some of the differences between a traditional OEM type of manufacturing operation compared to a Tesla.
Yeah, that's interesting. It's, as you're talking about that, like reflect back on the just kind of business model of Tesla. And there's advantages and disadvantages to being new in an industry. You can kind of come in hard and fast on setting a cultural tone pretty quick. And if you can scale that rapidly, then you kind of own that. Coming into, companies that are decades, 100 years old, it's a much different challenge to deal with some of the cultural shifts that are necessary, right? I want to talk about that a little bit more on the traditional manufacturer side. Talk us through some examples of factory initiatives. We could talk AI, but AI is new enough. I'm not sure that we've had a chance to prove them or fail at many of them yet. So talk to me just generally about, factory initiatives that you've seen struggle because of that cultural mindset or the fragmentation or oftentimes just lack of cross-site standards. What are some of the hurdles that you've seen them run into, and what are some of the fixes that you recommend?
Well, it's a big problem, I think, in a lot of manufacturing companies. Every plant is different, and every plant manager thinks his plant is different and unique. It's funny how you can walk into a McDonald's in Tokyo, Japan, and a burger tastes exactly like it would taste in Tulsa, Oklahoma. It's just, we don't have that same level of standardization within a lot of our manufacturing facilities. Now, I can tell you as a plant manager, as a vice president, as an operations leader, that was something I was always seeking. But you're constantly fighting against the inertia at the plant level, where there are reasons why people within those organizations think that, well, it may apply over in this plant, but our processes are different or better, or we don't need to do that. So I don't know. When I work with companies and when Mark and I are involved in initiatives, the one thing that we like to do is really get out there and walk the floor, talk to operators, find out what they're doing. What are their problems? I think a lot of people are familiar with Gemba walks, where you go see, you go touch, and that's really the way to start. You want to start in the plant, not start with the pitch. So it's you don't start throwing the PowerPoints up there and say, here's how we're going to do it. You need to get out there and really touch the process, find out, and see how much variability you're getting from site to site, because there will be some. Then you need to get in and find out what those drivers are. Some of it is cultural, some of it is technical. There are differences in processes. There might be differences in the age of the equipment, or where that maturity of the equipment is. So I think, those are the kind of things that you need to do. Really build your whole idea around the process, and then start looking at the standardization. And it needs to take place at virtually every level. I mean, and again, you can do this through pilots, but, you've got to make sure you've got the right KPIs in place. You're driving the right behaviors within the plant. I mean, if field goals counted for 6 points, you'd probably see a whole lot more field goals kicked than touchdowns scored. So, it's how you measure your results that will drive a lot of the behavior. So you really have to think it through. And then your governance process, how you manage that manufacturing process, has got to support those decisions. So I think that's really the kind of thing you want to make sure you've got in place. But Your point about standardization, and I'd like to talk more about that, to be honest, because it's one of the areas that's critical. You go into plants and you find that everything is different. The way that they wire, the way that they program, the way that they address their maintenance situations are all different. And there's a lot of places where that can pay off, but I don't think manufacturing is one of them. We want innovation, we want creative thinking, but it's got to be within an envelope. It has to be within a box that will guarantee a specific outcome from every one of those facilities, regardless. And that's where, and I've been involved in working in companies, at Ford and GM and Chrysler, where some plants are just better at this than others. The one thing that I've seen in all three of those companies is that the Mexican plants tend to be very, very rigid about this. They'll take that on and they will address that, as a standardization. They've got the language barrier that they have to deal with anyway. And as a result, they want to standardize everything, and they're really, really good at it. And I think at all three companies, I've seen, that they tend to be leaders in this particular aspect. There's a lot of other, things that the other plants are good at. But in this particular area, the Mexicans tend to do a really good job in this area.
That's a great place to pause part one of our conversation with Bruce Coventry and Marc Rosenmayr. So far, we've explored the practical realities of AI adoption in automotive, everything from legacy equipment and decentralized operations to safety concerns, data gaps, and cultural resistance. We also heard why engineering leadership and cross-functional alignment are so essential to building trust and accelerating transformation. In part two, we shift from challenges to possibilities and hear how a systems-level mindset is helping leading manufacturers reimagine product development, factory strategy, and competitive advantage.